right, we are at the final section of chapter 6, 6.8. 6.8 is focused on graphing square roots and graphing cube roots. So this video is going to focus entirely on square roots, and then I'll make a separate video that focuses entirely on cube roots. You will notice square roots are asked about more, so they are definitely going to be kind of the focus of this lesson. So first, we have a quick definition. A radical function is any equation that has a radical or radical exponent. And we talked a little bit about this when we talked about solving equations. Our focus, the specific radical one for this video, is what does it look like when I graph a square root graph, which you could definitely graph on your calculator if you needed help. So your basic square root function, we call it the parent function, is going to be this one right here. It starts at the origin. So that's kind of the origination of the graph. And then it looks like an arc that goes upwards. That is your basic square root function. Originates at the origin and then arcs upwards. If you put a negative in front of it, so let's say it's a negative square root graph, it still has that same starting point, but then it arcs downwards. It flips because that's what a negative does. It flips it upside down. So those are your basic parent functions of square roots. As far as domain and range, and I'm not going to do too much with domain and range of this, I'm really going to focus more on the looks here. Your domain for your parent functions here are everything from 0 to infinity because it starts at the origin and just keeps going to the right. And your range, which is going to be bottom to top, is also going to start at 0 and move up because, again, from bottom to top, it starts at 0 and goes upward. My domain is going to include any value that I'm allowed to plug in for x, and my range is going to be what I get for y. So here's the piece that you really want to either jot down, or you might look over this and go, you know what, we've done this so many times, I've got this. And it's how do we transform a graph? How do we move it? How do we shift it? And we've done this so much. We've done this with parabolas. We've done this with absolute value graphs. Well, now here we are doing it again with square root graphs. The number in front of the square root, if it's positive, it'll arc upwards. If it's negative, it will arc downwards. The actual number itself isn't going to change much. It'll make it a little steeper, but it's nothing that I'm going to ask about. Under the square root is going to be how we determine if it shifts to the right or if it shifts to the left. And here's a little grid here. This is something you might want to just jot down in your notes of here's the overall kind of, it's almost like a map telling you how to get from one place to the other. If you have a plus a value under the square root, it's going to move that many places to the left. If you have a minus, it's going to move that many places to the right. If you have the number afterwards is positive, we call it the k value. If it's positive, it's going to shift up that many spaces. And if it's negative, it's going to shift down. Now, as I shift these graphs, it is going to change things like domain and range. As I said, I'm not going to really focus on that very much. Your horizontal shift will change the domain. Your vertical shift will change the range. And then if A is negative, that also changes that range as well. So the first couple problems on here are just descriptive. What is the actual shift that's happening? So for this first one, what you'll notice is the only thing that's different is a -3 after the square root. So that means it's going to go down 3 spaces. The next one, underneath the radical, we have a +2. That's different than being outside the radical. Underneath the radical is going to shift it right or left. This is going to be to the left 2 spaces. This next one has a couple things going on. Since there's a -2 under the radical, it's going to go to the right 2 spaces. And since there's a 1 at the end, it's going to go up 1 space. And this last one is kind of like the trifecta. Everything's going on here. This is going to flip it. So it's going to make it arc downward. This +4 is going to make it go to the left 4. And the -5 at the end is going to make it go down 5. So what you're going to see on Delta Math, we've done ones like this where they give you that parent function again, which in this case is the solid black one, and they're going to ask you for the equation of the dotted one. So you have to go through and figure out what happened to it. Did it move to the right or left? Did it move up or down? Did it flip? Now, a lot of these are multiple choice. So you're able to look and say, okay, to go from, it started at the origin, but the dotted one starts at -5, 5. So it goes left 5 and up 5. So to go left 5 and up 5, we need to have a +5 under the radical and a +5 outside the radical. So your answer here is A. So that's what a lot of your questions will look like when it comes to actually writing what's happening here. Let me look back to the assignment. Oh, these were cube roots. Hold on. There are ones that are discovery ones. So your discovery ones are going to be the ones where you have to kind of fill in. And as you fill it in, it's going to move it for you. I like these. I think most of you like these because you can't get them wrong. So this one, it moves over 1, 2, 3, 4, 5, 6 places to the right. So that's going to be a -6. And then after it's moving, hold on, it's moving down 3 places, 1, 2, 3. So that's going to be a -3. And what's great about this is as you do it, it moves it for you. And if it doesn't end up on the right spot, it's not going to let you submit it. So you're going to have ones like that we did with like parabolas, things like that. So those are the biggest things you're working with these. Now, if it's negative, just to show you this one, if it has a reflection, let me show you an example of this. So with this one, since it's underneath, you're going to have to change the plus sign to a minus sign. That will flip it. It moves to the right 3, so that's going to be a -3 here. So there's moving that over. And if it moves the direction you don't want it to go, you just change it. And then it goes down 1, so we're going to make it a -1. And there it goes. So those are the types of problems you're going to look at. Some you're going to have to match, and some you're going to have to go through and manipulate it to get that dotted one to overlap. So you can kind of see that shifting that happens. So that is your square root graphing. Like I said, I think this section's really easy based on what we've already done. I'm going to make a cube root video next so that you're comfortable with everything.